Okay, let's continue using the chain rule along with other rules. So on example A right here, I want you to see that you have to do the product rule because this is being multiplied by this. Okay, those two things are being multiplied together. So product rule. But I also want you to see that what I underlined in purple is also a peanut M&M. All right, and so that means I have to use the chain rule on that when I go to do the derivative. Okay, so here we go. I'm going to try and take it slow. I'm going to try and talk it out. You may want to label stuff as we're going. All right, here we go. So I'm taking the derivative with respect to x. It's the first. That's easy. Now the derivative of the second, again, that is a peanut M&M. So the derivative of the peanut is 2. And then the derivative of the M&M itself is 4 times 2x minus 3 to the third. Okay, so that's the first times the derivative of the second. Then it's plus the second times the derivative of the first. All right, that's great. That's just step 1. So now we need to figure out if there is a GCF here out of these two terms, okay? And I know it seems like it's a lot more than 2, but this is one term and this is one term. And I am seeing that they have an x squared in common along with a 2x minus 3 cubed in common. Okay, and then because I started out with 2 terms and I factored out something out of the 2 terms, I should still be left with 2 terms. So let's see what we're left with. Here, I still have 8. Here, I still have 1x, but I have no more of these parentheses. They all got pulled out. On the second term, it looks like I still have this 3. I don't have the x squares, right? They got pulled out. And we pulled 3 of these out, so that means I still have 2x minus 3. Okay, so now let's clean this up just a little bit more. Inside the brackets, I'm going to distribute. So 8x plus 6x minus 9, and then I have some like terms. dy dx is now going to be x squared times 2x minus 3 squared times 14x minus 9. All right, that's awesome. Okay, let's take a look at B. All right, so the first thing I'm going to do here is rewrite it as 4 times 2x squared minus 4x minus 3 to the 1/2. Okay, so there's a very large peanut M&M going on here. That's what this whole thing is one really, really big peanut M&M. So I'm going to start with the peanut, which is the stuff in the parentheses, and I'm going to take the derivative of it, which is 4x minus 4. Then I'm going to do the 1/2 times the 4, which is 2. Then I still have my set of parentheses. And I'm going to subtract 1 from that exponent. All right, now continuing, this, all of it, is going to move into the denominator, right? It's going to be the square root of 2x squared minus 4x minus 3. And up top, this is factorable. I can take a 4 out of there. So when I take the 4 out of here and multiply it by this 2, I now have 8 times x minus 1. Okay, let's move it on up. Continue. Okay, so my peanut is right here. So the peanut derivative is just 2. dy dx equals 2. And then the derivative of cosine is negative sine, and the angle remains the same. So when I clean this up, dy dx, all that I'm really cleaning up is this. The order of this looks funny. It kind of looks like subtraction. when it in actuality is multiplication. So I just want to make sure that it looks more like multiplication. Okay, buckle up, buttercups. Here comes a really lengthy algebraic problem. Okay, this may stretch your minds just a bit. Okay, and here's the reason why. This is a product rule. It's this peanut M&M times this other peanut M&M. So every time you have to take the derivative of the peanut M&M, you're going to have to do the chain rule. Okay, here we go. Let's see if we can take this as reasonably slow as possible. All right, so the derivative. So it's the first. That part's easy. Times the derivative of the second. Okay, the derivative of the second is first the derivative of the peanut, and then the derivative of the entire M&M. Okay, so I've done the first times the derivative of the second. Plus, now it's the second times the derivative of the first. Derivative of the first is a peanut M&M. So the derivative of just the peanut is 6x squared. And then the entire M&M is 5 times 2x cubed minus 7 to the fourth. Now, since I know that I'm going to have to factor this, right, because that's what I always make you do, is I always make you factor, I'm noticing right now that this term right here is factorable kind of on its own, as is this one, and there are two of these. So I'm going to clean this up a little bit before I do the main factoring. Okay, so let me show you what that looks like. I'm going to take a 2 out of here, which multiplies with this 2 and with this 4, giving me 16, 2x cubed minus 7 to the fifth. And since I took a 2 out of that parentheses, I now have 2x plus 1. Okay, now let's take a look at the other side. There's 2 of these parentheses, and they each have a 2. So that means I actually have a 4 that I'm taking out. So when I multiply that 4 times this 6 times this 5, that's 120. And then there's, let's see, this x squared. And then I still have what's left out of here when I pulled the 2 out. So 2x plus 1 squared. And then I haven't touched this yet. 2x cubed minus 7 to the fourth. Okay, so all I've done so far is factored each term and cleaned it up. All right, now these two terms, 1, 2, do have a GCF. Okay, here we go. The GCF of those is 8, because there's an 8 in the 16 and an 8 in this 120. 2x cubed minus 7 to the fourth, because this one has 5 of them, but this one over here has 4 of them, and 2x plus 1. Okay, so that's the GCF. Let me try and label this. GCF. All of this is the GCF. But that still means that I should have 2 terms left. All right, so let's see what's left. If I took 8 out of 16, I still have a 2. And I think I still have a 2x cubed minus 7 left. And then out of the second term over here, when I take an 8 out, I'm left with 15 and an x squared and a 2x plus 1. Okay, now that may mean right now, guys, that you need to like pause the video and really think that through. All right, next what I'm going to do is I'm going to clean this set of brackets up. So the GCF is fine. All right, so distributing, I get 4x cubed minus 14 Distributing over here, I have 30x cubed plus 15x squared. And again, now there's some like terms to combine. So 8 times 2x cubed minus 7 to the 4th times 2x plus 1. All right, let's see. How many cubes do I have? 34. 34x cubed plus 15x squared minus 14. That should be parentheses. All right, like I said, buckle up. All right, let's keep going. All right, so here comes quotient rule. Quotient rule, right? That looks like a fraction, but it also looks like that fraction has a peanut M&M in the numerator. So it's going to be low D high minus all of that. All right, here we go. Low. Now, D high is a peanut M&M. The derivative of the peanut is 2. The derivative of the entire M&M is 3 times 2x minus 1 squared. And then that's low D high minus high D low, which is 5. Square the bottom. And away we go. Okay. This is definitely going to need some cleaning up. Let's see. There's a 6 here. So it looks like I may have 6 times 5x minus 6 times 2x minus 1 squared minus 5 times 2x minus 1 cubed all over 5x minus 6 squared. Okay, now when I go to factor the numerator, it looks like the only thing I have in common there is a 2x minus 1 squared. 2x minus 1 squared, which leaves me with 6 times 5x minus 6 minus 5 times 2x minus 1 all over 5x minus 6 squared. And then in the numerator, in the brackets, I need to distribute some stuff. 2x minus 1 squared times, let's see, 30x minus 36 minus 10x plus 5 over 5x plus 6 squared. I'm running out of room. Let's see, 2x minus 1. So this big long thing does have a couple like terms. 20x minus 31 over 5x plus 6 squared. Okay, and then this last one, again, there are going to be some trig functions that involve the chain rule. Let me rewrite this for you. It's cotangent x to the 6th. Okay, it's so much easier to do the chain rule when you see it in this form because it looks now more like a peanut M&M. So when I go to do the derivative of cotangent is negative cosecant squared x. Then the derivative of the entire peanut is 6 times cotangent x to the 5th. All right, now the only thing you have to do when you clean this up is put this 6 sort of out in front because it's a coefficient. And you end up with negative 6 cosecant squared x cotangent to the 5th x. All right, see you tomorrow.